Let's work on this problem. Part A, so they give us a probability distribution. Probability distribution is basically a frequency distribution. It's basically a frequency distribution, except that the second column, instead of frequency, it's probability. So the whole thing here will be called probability distribution. So the word distribution for now can be understood as a table. So frequency table, frequency distribution, probability distribution, probability table, like that. Okay, now part A, verified that this is a probability model. How do we know that it is a probability model? When we add the probability here, we get 1. Okay, but let's check. Let's check. When you add this, does it give you 1? Yes, because first, the probability of each effect is 0 or positive. And second, and it has to be both. The total probability is okay. Now part B. What is the probability that a randomly selected family with at least one child younger than 18 years of age in 2013 has 2 married parents in the first marriage? Two married parents in the first marriage. So it refers to this one. Huh? Okay, Thomas, the wording is confusing. I'm sorry. That's part of the learning process. Okay, we want to apply this to our real life, right? So we need to be able to, of course, read, understand the context, and then apply what we learn. So probability of getting 2 married parents in the first marriage is 0.46. Okay. Part C, what is the probability that a randomly selected family with at least one child younger than 18 years of age in 2013 had 2 married parents? 2 married parents. Part C seems to refer to 2 married parents, both of these. Okay, 2 married parents. So 2 married parents refers to 2 married parents from first marriage plus 2 married parents, one or both remarried. So that's 0.61. What is the probability? Part D, what is the probability that a randomly selected family with at least one child younger than 18 years of age had at least one parent at home? at least one parent at home refers to two parents plus one parent. So it refers to this one. Yes, actually we can also say it that way. Is it complement of no parent at home? Yes, it's also possibly done that way. Okay. So let me do it my way first, and then I show you that it is equivalent to what our friend said. So at least one parent. That refers to 0.46. Two married parents, first marriage. Two married parents, one or both may be married, plus single parent. That will give us 0.95. Now, that's the first method. That's the first method. The second method is by what our friend said. The second method, using the complement. Using complement, that is 1 minus the probability no parent. Now, if you read 5.3, then you will see this is what we can do. Okay, which is 1 minus 0.05, that is 0.95. So you see, either you add the events one by one, or you look at the complement event. Okay, either way is possible. Now, I hope you will see that even though I still assign you suggested homework, not to turn in. It is just suggested homework from your textbook, but I tend to have my own set of examples. And when you look at my tests, my previous tests, you will see that I don't go too much into word problems yet in my test tool. I still have some, but not a lot. Because in my opinion, when I go too much into readings, I'm afraid that we get too much into details without a good, strong foundation in the theoretical foundation. So you still need to practice from the book, though. Okay, I'm not saying that I'm not taking problems from our textbook. No, that's something that you need to train also. Okay, but the foundational theoretical foundation is actually from my lecture. When you apply that to word problems, that's where you get it from textbook. And yes, you see that the textbook problem tend to be longer, right? We can just say that this is A1. I mean, we can call that something else. We can call this maybe I use another color. I can call this A1, A2, B, and none, for example. Okay, and then question part B, I can say find the probability of A1. Part C, I can ask the probability of A. And part D, the probability of A or B, like that, right? Okay, much less problems, much less wordings. Okay, yeah, but of course, then when I use A1, A or B, you may say that, oh, I will never apply this to my real life anyway, because who will deal with A or B in their life? Oh, that's true. But when I make it into word problems, like a problem from this textbook, then you will say, oh, you know what, it's too much wording, the wording is confusing. So either way will be something wrong, huh? No, I hope you see this as first, when I make it this way, it's more into the theoretical view so that you can focus on the probability, and our textbook way focus on the application, okay? So we can go both direction, and we will go both direction. Now, let's go back to our lesson, and this is just to warm us up, right? I will do more problems. Let's do this problem. For example, suppose we have a Venn diagram. Okay, still warming up. A Venn diagram. Okay, of people taking math and people taking English. Now, suppose I say this way. I will need you to construct the Venn diagram. Okay, suppose I say, suppose of 100 students, it is found that let's say 65 take math, and then how about 47 take English, and 23 take both. Now, how you decipher this into a Venn diagram? We have 100 students. So the total numbers in this rectangle in this Venn diagram should be 100. Okay, 65 take math. So the numbers in this circle here should be 65. Okay, 42nd take English. So the total numbers here should be 47. Okay, and 23 take both. 23 take both. So from here you see that we need to work it out, work it inside out. I need to do this 23 first. Okay, that's 23 here. This 65 take math, when we say 65 take math course, it doesn't mean only the 65 take math only. No, it doesn't say math only, it says take math. Okay, 65 take math. 23 of this 65 also take English. Now, so if 23 take both, how many people take math only? Then that will be 65 minus 23. Is that right? That will be 42. Why? Because the total has to be, the total in this math circle should be 65. Is it right? Okay. So let's go back. So in math, that will be 42. Then how many people take English only? That would be 47 minus 23. That is 24. Is it okay? So when you do your reading, when you read this, be careful with your assumption. Okay? When we say 65 take math, it doesn't say 65 take math only. No, those are two, it's very different. It's very different statement, 65 take math and 65 take math only. Okay, now so far we are done with the circles, but there's still one issue. We're supposed to have a total of 100 students. So in this rectangle here, inside this rectangle, there should be 100 people. Then how many students not taking math and not taking English. That's the one we put out here. Okay, and our friend says it's 100 minus 42 minus 23 minus 24. That's right, which is 12. That will be 12 here. Now, just in case somebody asks me that question, how do you get this 12, Thomas? And we get it from 100 minus whatever we have left in there. I think it's not 12, huh? Wait, that's 89. That's 11. That's 11. Okay. Don't do that to me, please. Don't do this. Oops. Erase it, please. You know what? Okay. Yeah, basic, but the principle is correct that it's 100, the total 100 minus whatever we already have in there. That's how we get that 11. So notice that this Venn diagram then satisfies that there are 100 students, 65 take math, 47 take English, and 23 take both. Okay. Let me erase this. Erase this. Maybe I circle this with red. That's the one not taking math nor English. Okay, now let's see. Suppose we select one person at random. Suppose we select one student from this group. At random. Then, so let's say part A, find the probability that person take math. Then we see how many people in math? 65, right? Okay, let me write it this way. Let me write it this way. That's 42 plus 23 over 100. That's 65 over 100. In decimal, that is 0.65. I think in this case, it's easier to do decimal. Now, how about the probability of taking English? Notice that my notation here, the question here is not taking English only. This is taking English. That will be 23 plus 24 over 100. That's 47 over 100, 0.47. How about probability of not taking English? So the notation will be like this. Our textbook, by the way, our textbook will use this notation. Okay, that's what our textbook will do. Now, either notation you use, how do we compute it? There are two ways to do this. The first one is compute those not in English. Compute those not English, not taking English. 42 plus 11, right? Not taking English. So kind of like you cover this English. You cover this English. Then you see, oh, 42 plus 11, that is 53 over 100, which is 0.53. Okay, now that's the first method to do that. Another method, the second method, you can also say, oh, you know what? The complement of English is, the probability for the complement of English is 1 minus the probability for English, which we happen to have done in part B. That's 1 minus 0.47, that is 0.53. Okay, now the first method of doing this, we refer to the Venn diagram. The second method, we use formula. Which one you like, Thomas? Either way, just show me either one of them. Okay, what I cannot accept is you just write 0.53 right away. Okay, now I cannot accept that. I need you to show me either this or this. Okay, so it's about the work, not only the final answer. Well, right now you may say, but Thomas, it's just too easy though. I can do it in my head. Why probability is hard, at least in my class? Because of what you think. If you can do everything in your head, then we don't need to take this class as a separate class. And we will not take this class as a course transferable to UC system. And be very careful with that argument though. The argument of this, why don't you show work? And people like to answer me this way, because I can do it in my head. Yeah, to these people, I usually joke that, okay, let me give you your grade in my head. No, you don't want it that way, right? Remember, when I grade you, I have to grade you based on what you write, not based on what I think you write. Okay? When I grade you, listen to me, when I grade you, I have to grade you based on what you write, not based on what I think you write. Okay? I have one wife, that's enough. Okay, she is the only person I have to read her mind, and I'm still working hard for that. Okay? You know, I love my wife so much, that's why I want to do it. Okay? Now, I never see you in person. What makes you think I have to do it for you? Okay? No, I understand, but still, when the definition of being fair is that I apply the same rule to every student, right? And that is, when I grade you, I have to grade you based on what I have, such that I have an evidence to support the points I give you. Okay, it's not that I don't love my students, that I try to penalize them a lot. No, it's just common sense. You help me writing it down so that I can help you giving you the point. Okay, if I don't have evidence that you deserve the points, then I cannot give you the points. Okay, now continue from this argument, because I can do it in my head. Now, what if you can do it in your head? What if you can do it mentally? Now, most people will think, then I will try to work it out in writing. Seems to be a reasonable argument, huh? No, it's not. It's not reasonable. Let me tell you why. Because when it is easy, you don't get used to write it out. When it gets hard, what makes you think you can write it out? Okay. In other words, you don't show work because you can do it in your head. What if you cannot do it in your head? You can't even write it down. So in either case, either you can do it in your head or not, you will not write anything. And the reason is because you never practice to write it out. Do you want to wait until it gets harder? Okay. Now, it sounds like I'm getting math with you. No, I'm not getting math with you. Don't worry. It's too early for you. I just want to tell you that that's the song that I heard too often in my teaching career. At West LA College, I've been teaching for, this is the end of my 13th year. Okay. And not only for statistic class, even for other classes. I heard that a lot. Thomas, I did it in my head. I did it in my head. Okay, I did it mentally, fine. Okay, but in the test, when they left it blank, I asked them, why don't you do it? Why don't you show your work? They said, well, I cannot do it also. You did it in your head usually, right? You know, sarcastically to them, you did it in your head, right? Okay, now let me give you the grade in my head too. I really want to say, I told you, work it out, okay? Now, not that I want to get mad with them, not that I want them to feel the pain, no. How do you want me to tell you that you should learn to write it down, okay? So that in your test, everything becomes smooth, right? What you think and what your hand writes is actually parallel. You don't need to stop writing. You just keep on writing, and then eventually finish the test. That would be the best storyline, right? Okay, your hand keep on writing, at the same time your brain keep on thinking. Instead of you think, but you stop writing, and then when you write, you stop thinking. No. Your mind and hands supposed to be parallel. Okay, they're supposed to be able to work at the same time. Anyway, that's too much lesson from that side. No, I don't need to actually talk about that, but my purpose is I want you to be, especially in this case, to be a good statistician. Okay, at least a junior statistician, in which when people ask you question, you are able to explain it in writing in the way that people will understand what you write. Then they will say you are smart, even though you may not be smart. It doesn't matter. Okay, what you need is you look smart. That's good enough. Okay. Now let's make it harder. Once it gets harder, it's confusing. I know. Let's see the following question, part D. Find the probability that if you select one person at random, that person taking math or English. Either that person take math or English. Now, when we use the word or, it means it satisfies either one of them. Okay, once it satisfies math, you count it in. Once it satisfies math, you count it in 42 plus 23, and then satisfy English, you count it in 23 and 24, but 23 already counted. I don't count it anymore. And we get 89 over 100, which is 0.89. Part E, what is the probabilities? We select one person at random. That person will take math and English at the same time. This one is easy. This is 23 over 100. Now, of course, these are all textbook questions. In other words, the difficulty level is basically textbook difficulty. No fun. And if somebody needs to hire you to answer this kind of question, you can imagine what kind of company that is. No, I don't expect any company will hire you to do any one of these 5 questions here. No, okay? You should be able to do something harder than this. And anything harder than this is the one that we focus on. For example, part F. What is the probability that when you select one person at random, that person take math, but not English? that person take math but not English. That person take math but not English refer to this part here, right? Now we can say this way. We can say this way. We look at the math first. Okay, but we take this away. We take this away. Math, and then you cut away those people who take English. Is it okay? Now the thing is, we can also say this is math only. What is the probability we select somebody who take math only? Right? But another way to say it is math, but not English. Okay, that's how we get that 42. But Thomas, why don't you just say that math only then? You make life so difficult. Well, if I have that right, that would be a lot worse. No, I'm kidding. No. So there are more than one way to express an event. Okay, math only, math and not English. In this case, that will be 42 over 100. Now, how about part G? 0.42. How about probability of not taking math and also not taking English? Not taking math and not taking English. Not taking math means outside of this math, outside. So I kind of like dark it out. Okay, not taking math refers to 24 and 11. Okay, but at the same time, that person should not take English either. So I need to dark this out. Boom. So what is the number that is not in math? That's 24 and 11. And also not in English, that is 42 and 11. Okay, so how many people not taking math and not taking English? Not taking math and not taking English is 11. That's right. That will be 11 over 100. That's 0.11. How about part H? Probability of taking math or not taking English. It's an or. Taking math or not taking English. Now remember, the or means as long as it satisfies either one of them, you count it in. Okay? As long as it satisfies either one of the requirements, you count it in. It's different from intersection. For intersection, it has to satisfy both. Okay? Intersection, it has to satisfy both. Union, it satisfies either one of them. So taking math or not taking English. Taking math refers to this, which is 42 plus 23. I count it in right away, right? Once it satisfies one of them, that's 42 plus 23, plus those not taking English. The one not taking English are this guy and this guy, right? So 42 and 11, I already have 42, I cannot double count it, I count the 11. That will be 76. That's 0.76. Okay, now over 100 here, Thomas, why do we divide over 100? Why is it over 100? We have done this all the way. Why over 100? because there are 100 students to select from there, and each one of them equally likely. Okay, then you try this then. HI probability of selecting someone not taking math or taking English. Taking math, not taking math or taking English. Can you do that? Now, can you tell me what number do I need to add? Not taking math refers to how many people? Not taking math. 24 plus 11. Plus, how many of them take English? There are 23 plus 24 people taking English, right? Okay, but we already count 24, so I just add 23. See it again. Okay, not taking math refers to this guy and this guy not taking math. Or taking English, this guy and this guy. Right? That's why then when I add 23, 24, and 11. Is it okay? That's 100. What will this be? 68 over 100. That's 0.68. Okay. Now, let me ask you to do a more complicated problem. I know this is more complicated. Yeah, you copy that down first, and then I show you in a second. $0.58. I think is, yeah, that's right, 0.58. Okay, thank you. Let me check. Let me see. I would like to take problems from my old tests. Give me a second. I need to go to my old files. Let me see from 418. This is one problem I have from my old test. So if you don't practice it now, you may get some issue on Monday next week. Let's say we have this situation. Now let me ask you to copy this Venn diagram first. Please copy that Venn diagram first. And then we would like to answer this question. Suppose we have that Venn diagram. Let me ask you to answer these 7 questions here. Probability of B, probability of A intersection C, A union B, so on and so forth. The last 4 questions are the hard ones. The first 3 are basic. Let's do some basic work first. Let's find the number of elements in the universe. The number of elements in this sample space. Okay. That's the first thing you will do. Okay, so probability of B here will be, probability of B there will be whatever you have here on the denominator. Okay, and let me give you some time to work on this. Let's say 1, 2, 3, 4, 5, 10 minutes. No, you don't need 10 minutes. Maybe 7 minutes should give you a good idea already. Okay, let's work it out. The total number of elements in this Venn diagram is 64, right? Okay, now then when we ask what is the probability of selecting one person from B? What is the probability of selecting one person from B? Then it will be over 64, because in total there are 64 possible element to be selected from, each one of them equally likely, and the probability of getting B's will be the total number of elements in B divided by 64, right? That will be 6 plus 4 plus 7 plus 3. That's 20 over 64. Now you can leave it in fraction, but if you do leave it in fraction, make sure you simplify. Reduce by 4, reduce by 4. Okay. Now, of course, you may say, Thomas, can I just write 20 over 64? Yes, you can, as long as you reduce it or change it back, change it to decimal. Okay. But when you write 20 over 64 only without writing this, if you don't write this, very likely tomorrow you may look at the same question and you don't know how you get the 20. So think of it from your learning purpose, right? You don't want to write something that you don't understand tomorrow. So write it in a way that when during the weekend, especially when you study for your test, you know how you get that 20 from. Okay. Now, part B, what is the probability we get somebody from A and C at the same time? Because we select from the whole Venn diagram, that will be over 64. And intersection of A and C, so it has to be this here, right? Okay, so that will be 2 plus 7. That's 9 over 64. That's easy. How about probability of selecting somebody in A or in B? Again, we still select from that whole Venn diagram. Okay, it's either in A or in B. So either A, which give us 17 plus 6 plus 2 plus 7. That's for A. That's for A. Right? That's for A. Plus those in B. Those in B are 6 plus 7 plus 4 plus 3. But 6 and 7 already counted. You see what I mean? 6 and 7 already counted. See, remember I warned you ahead not to do it in your head, only try to write it down. Okay, because you need to focus on the procedure instead of just final answer. Yeah, focus on the procedure. Now, such that when it gets harder like this, like more problem, then you know what to do. Okay, now let me go back. There's too much to write. If I write it that way, a lot of you tend to get confused. I mean, I myself feel overwhelmed with so much writing there. Okay, I will just write it this way. Okay, I get the A's, the ones from A, 17 plus 6 plus 2 plus 7, plus those in B that had not been counted. 4 plus 3. Okay, now when I add them, 10, 22, 39 over 64. Now, how about part D? Probability it is in A, but not in B. Probability that it is in A, the ones in A are 17 plus 2 plus 6 plus 7, but I need to cut away those in B. I need to cut away those in B. I need to cut this away, I need to cut this away. Because it has to be in A at the same time, cannot be in B. Right? Okay, so that will be 19 over 64. Part E, probability in B or not in C. Again, we take it from the whole Venn diagram, so it's over 64 possible elements to choose from. Those in B, this is the one in B, this is the one in B. Okay, let me add them up first. That will be 6 plus 4 plus 7 plus 3. Now, it is an OR. It is an OR, which means we just add whatever in the second requirement. Okay? Because OR implies it has to satisfy either one of B or not in C. Not in C refers to this guy, this guy, this guy, this guy. Okay, so what else I need to add here? I already get the one in B. Now I also need to include the ones not in C. That's 10 plus 17.
Professor.
Yes.
So for this one, I don't know if I missed it. I probably did. We're just adding everything that's not in C.
That's correct.
Okay.
Yeah. And not in C refers to 10, 17, 6, and 4. Now, but I don't count 6 and 4 anymore because I already counted in B earlier, right? We should not double count that. Does it make sense? Okay, maybe I use a different color. Give me a second.
So do we still add the 7 with 3, even though it's in 3?
Give me a second, okay? Give me a second. Okay, this is the one in B. Right? This is the one in B. Right? Now, this is an OR, which means once it is in B, you count it in. Now, how about the C part? Not C. Not C refers to this guy, this guy, this guy, this guy. That's not in C.
Okay.
Right? Now, because it is an OR, then as long as it is yellow or green, I count it in. It's an OR. So I will have plus, I'm supposed to add 10 and 17 and 6 and 4. But the 6 and 4 already counted earlier.
Okay.
Right? That's why I don't count it anymore. Okay?
Okay.
Yeah. So then You know what? Let me just leave it like that, huh? Let me just leave it like that. So then this is equals to 20, that's equals to 47 over 64. So be aware that the difficulty actually happens when we deal with intersection or with the union or with the complement. There's nothing difficult with intersection itself, nothing difficult with the union itself, nothing difficult with the complement itself. It gets difficult when they start to interact.
So if it was an and situation, we wouldn't count the 7 and the 3 in there?
Repeat it again.
If it was an and question, we wouldn't count the 7 and the 3?
In fact, if that were an and question, so B and not C, I will not count 7 and 3. I will not count 10 and 17 either.
So
Because for intersection, it has to have two colors. It has to satisfy both situations. For or, it just needs to satisfy either one of them.
okay.
Okay. Before I finish these problems further, let me illustrate this for you. Okay. By the way, this illustration is a real life question. A real life question. When I was around 13 or 14 years old, this is serious. It's a bit funny for me, but because my mom the one asking me this question, I remember that pretty much forever. She asked me this question, Thomas, when I was 13, for God's sake, 13 or 14, I remember I was in middle school at the time. She asked me, this is what my mom asked me, Thomas, what kind of girl you want to date and marry? Okay, I think there's no mom in their right mind will ask a 13 or 14 years old boy this question, right? But she did ask me this question. She did ask me this question. And I remember very well, my answer was someone who is nice and cute and smart and rich. That's my answer. And you know what my mom did at that time? Once she heard this, she rolled her eyes. She rolled her eyes. And she kind of like gave me that smirk, right? It's like, and then I say, Mom, why are you laughing at me? Kind of like, are you teasing me? And then she said this, Thomas, yes, of course, it's nice if you can marry such kind of girl, you know, but even if you can find that kind of girl, even if you can find someone who is nice, cute, beautiful, right, and smart and rich, even if you can find someone like that, what makes you think that girl wants to date and marry you? And I was just like, Mom, that's so degrading. Mom, you look down on your son. And then she said this, first of all, Thomas, take a look at you. You want someone nice, but you yourself always talk back to your mom. And Thomas, look at your face. Your face is random. She was talking about me, and I said, Mom, if my face random, that's your fault. I get it from you. You know. I said, well, you get it from your dad. And then my mom said, well, I give you you are actually not so bad. You are not too smart, but not on at the bottom of the class either. So yeah, you're okay. You cannot call yourself smart. And we are definitely not rich. We are very poor. I come from very poor family. Now, given your situation, Thomas, given your situation, what makes you think this kind of girl will even look at you? And then I told her, I will show you, Mom. I will show you. Yeah, I will show you. And then, of course, I try to find somebody who is nice. Once I find somebody cute, then I will kind of approach that girl if she is nice. When I find that girl to be cute and nice, well, maybe that person not smart. So, no, I stop there. When I find somebody who is cute and nice and smart, it turns out that person is not rich enough. You see, I'm kind of like materialistic, right, huh? Okay, and I back off. Now, the thing is, once I find somebody who is nice, cute, smart, and rich, that girl is the one back off. So you see, it turns out that I have very, very hard time to date anybody. Why? Because I have too much restriction, right? Now, I'm not saying there's no such girl who is nice, cute, smart, and rich, but because I have so much requirement, that person has to be nice, has to be cute, has to be smart. Even with these three first requirement, I have already a very small set, right? Not to say that the rich people usually kind of arrogant. I'm sorry, but yeah, those are the one I see so far. Okay, not in general, but the one I interact with, you know. So I will end up with a very, very small piece of population that actually first nice, cute, smart, and rich, right? And it turns out even when I find that kind of girl, that girl don't want to look at me. And it takes me many, many years until I almost expired. Okay, from Asian culture, when you are past 30, at least this is what my mom told me though. That's not true in America. This is not true in America. You have a very good chance to get married, whatever your age. But back in Indonesia, for example, when you start reaching 30, then they use the word expired from you. Okay, then instead of using finding someone nice and emphasize that and cute and smart and rich, I then say, you know what, I changed this requirement. Instead of you are nice and cute and smart and rich, I change it to nice or cute or smart or rich. Guess what? In a couple months, I date somebody. Why? Because when we say nice or cute or smart, when you use the word or, means as long as it satisfies one of the requirements, you count it in. Right? See, my probability gets a lot larger if when I use the word or. Okay? Now, this conversation is a real conversation I had with my mom, by the way. But of course, what's her point when she asked me that question? How can you ask a 13 or 14 years old boy what kind of girl you want to date or marry? I don't even make my own money. Okay? But my purpose, my mom's purpose at that time is to tell me one thing. If you, Thomas, want this kind of girl, you better be that kind of guy. To match her. So my mom told me that, such that since the very, very beginning, I use the same standard I apply to other people to myself. So Thomas, basically, do not expect somebody to be nice to you if you yourself not nice to them. Okay? Cuteness, you are random, so don't expect too much from your face. Okay? How about being smart? You don't need to be smart, Thomas, you just need to look smart. But for you to look smart, you need to study. And rich will come after you work. In other words, yes, you want a rich person, you better work your ass off. Okay, now of course, right now I'm married and I have 2 kids. I cannot say that my wife satisfies all these 4, but I'm happy. Why? Because I feel like I actually match with my wife, right? Okay, she's nice to me just as I get nice to, and we get nicer and nicer each day. It gets better, okay, and because I get used to her, and once her face a little bit change, I will feel strange. I think that's the cuteness of her. Okay, and I don't think, trust me, I hardly consider myself smart, but I work very, very hard. And I can say right now, I marry somebody who really dedicate herself also for her purpose, which is basically her husband and her children, her family. And is she rich? No, but she is someone who is rich in her heart. Okay, it's so romantic, huh? Anyway, I hope using this illustration, you see that when you use and, then the intersection gets smaller. That's when you use and. When you use or, the union gets larger. Okay, I hope you see that something makes sense. Okay, now let's erase this because it's just an illustration. Now let's go back to our question here. Part F, not B and not C. It means it has to be 2 color. It means it has to be 2 color. Not B refers to this guy, this guy, this guy, this guy. That's not B. And not C refers to this guy, this guy, this guy, this guy. Now, because it is an and, then we will see the one satisfy both. Now, how many elements satisfy both not B and also not C?
Just 17 and 10.
17 and 10, that's right. That's 27 over 64. Okay, now can you try do some little follow-up? Suppose you need to answer this question, probability of not B or not C. Can you tell me what numbers I need to add?
Seventeen, 2, 7, 10,
17. What else?
2, 7.
7. No, we don't get 7. It is an or. It is an or. It is an or. Which means as long as you color it once, you count it in. Is it okay? So yes, that's right, 17 and 2 and 10 and 15 and 6 and 4. Okay, these are the number of elements that satisfy either one of the requirement, not B, which is the yellow, not C, which is the blue. Okay, over 64. So the difference between union and intersection, it has to be two color. It has to satisfy both requirements. For union, it just needs to satisfy one requirement. So once it has a color, you count it in. Okay, now let's apply that to part G. Let's apply that to part G. Not A, outside of A, that's not A, or not C. Because it is an or, once it satisfies one of the requirements, you count it in. That will be, let me do the yellow first. 10 plus 15 plus 3 plus 4 plus the blue one, but make sure it's not double counted, plus 17 plus 6 over 64.
So you basically don't count the numbers where the two intersect?
I don't count it twice.
Saying like, since you didn't get the 2 and a 7, you wouldn't count those since A and C intersect right there, right?
That's right. Yeah, but instead of looking that as A and C, just focus on not A or not C. That's actually better seeing it that way. Right? I mean, stick with the problem. Stick with the problem. Okay, so that's 20, 30, 40, 55. So that will be, this is 55 over 64. Now, actually, the same thing can be done with the contingency table. Now, let me ask you to copy that down first while I pick a question from our textbook. Our textbook tend to work with contingency table, but I tend to work with Venn diagram to balance it. Okay, now once you're done with copying that down, let me ask you to do this problem. Question number 40 in your textbook. You can skip part A and B. You can do that too. Let's say, and they already give you the summation though. So they already give you this sum here and then this sum here, which is very nice, help you a lot. Okay, you can answer part A and B quite easily. Part C and D will take a bit more effort. Okay, now I would like you to write the notation, the probability notation, then compute. This should take you around 5 minutes plus 5 minutes break. We come back at 9:30. Part A, what is the probability that for a married couple selected at random, so this is the set of the frequency distribution of married couple with children. Okay, I mean the married couple, and they list who works and how many children they have. So probability that both work is both work refers to this, right? So the total is 1,149 over the total 1,700. Now then, of course, use your calculator to make it decimal. I get 0.67588. Remember 5 decimal places. Part B, what is the probability that for a married couple selected at random, the couple has one child under age of 18? The couple has one child under age of 18. Probability of having one child. That is 353 over 1,700. That is 0.20765. It's supposed to be 647, but I found rounded to 5 decimal places, right? Part C, probability of having two or more children, and both spouses work. So, two or more children and both work. Now, what will that be? It's an N, which means it has to be satisfying both. It refers to this number here. Okay? The situation when the couple has two or more children and at the same time both of them work. That must be a very, very hard situation. I think in this case, yeah, I cannot expect that to happen. I have two children. That's it. That's too much for my wife. You know, it will be expecting too much from my wife if we have two children plus at the same time she needs to work. Okay. Yeah. So it's not that I don't take care of my children. I do, but I have to be honest. I trust my wife more in dealing with my children most of the case compared to myself. So this will be 370 over 1,700. Okay, what would that be? That's 0.21765. Yeah, 647 also. Part D, what is the probability that for a married couple selected at random, the couple has no children, the couple has no children, that's no children, or only the husband work. Only the husband works. So no children refers to this, or only husband work. Now you will see basically I need to add all the numbers here. Right? I need to add all the numbers here. Okay. Now when I add this part, I get what? 788 plus when I add this part here, I get 425. But you notice that this 172 is added twice, right? So I have to subtract that once so that it is only counted once. Okay. So this will be 788 plus 425 minus 172. I get 1041 over 1700. That is 0.61235. Now part E. Will it be unusual to select a married couple at random for which only wife works? Only wife works. Will it be unusual? Now, to answer that unusual question, an event is unusual if the probability is less than 5%. That's the rule of thumb. Now, this 5% cutoff is not set in stone, but this is the numbers we usually use in social science. Okay, like in daily life, we use 5%. Of course, in medical field, especially when it has something to do with life, then we usually set it at much, much lower than 5%, to the point of 0.5%, as I remember. Okay, yeah. So to answer this question, is it usual or unusual to find a married couple that only wife work? Then we need to see the probability that only wife work will be 126 over 1700. That will be 0.07412. So is this more or less than 5%? This is 7.412%, right? Which is more than 5%. So the conclusion is it is not unusual. Okay. It's not, of course, we have more case where only husband works or both of them works, right? But it is, we cannot say it is unusual for only wife work. Okay, it's not unusual for only wife work. And I believe recently this number is actually increasing to get into some social situation. Okay, now I'm not trying to solve any social injustice problem though. Okay, but let's talk about the trend instead of just seeing the problem we have right now. Let's take a look at the trend. A long time ago, this number is a lot lower. I don't think, oh, I have to go back and then say this here. These numbers are hypothetical. So please do not take these numbers as the true number. No, 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 this is hypothetical. This number is hypothetical. So the number that we get here, also hypothetical, okay? Now, but what I want to say is this, long time ago, the number, the proportion, the portion of a married couple where in which the only wife works is a lot lower compared to now. And the reason is, I believe, it has something to do with the pay gap of male and female. Now, I'm not saying right now we don't have this anymore. Okay. Now, I know some people say there's no more. Some people say there's still a big gap. I personally believe from the numbers I have seen that we still have pay gap, but it's actually not as bad as before. So saying that, do we still have this problem? Yes. Do we have to solve this problem? Sure. But are we going to the right direction? I think so too. Okay, so we should get better with this. And I believe this pay gap issue, male and female going to work. Okay, imagine if a female get less pay compared to male, then of course for that married couple, for that particular couple, when they need to decide, then they will decide let the husband go to work so that the family can earn more, right? Okay, that's the consequence. Okay, but because the pay gap get better right now, I mean get less, so it's better, right? Then we will see more and more married couple in which only wife work. Of course, you will also see more and more both couple work. Okay, now I told my wife she is very well qualified to go back to workforce, my wife. Okay, but we decide, you know what, her passion is actually to take care of my children, and I'm so happy with how she takes care of my children, especially my son. I wonder if my son is already wake up. My son is 3 months, three years, 6 months, plus 1 day, plus 1 day. Let me talk about this, my son. Oh, I love her. I love him so much. 3 years old, 6 months. Since he was around almost 3 years, actually still 2 years something, he already know how to count from 1 to 10. Right now, if we give him time out, for example, the punishment is not that, okay, you stay in that room for 5 minutes. No, the punishment is like you need to count from 1 to 200. So the faster he can finish it, the faster he gets out from that room. Okay, if he makes something quite terrible, then the punishment will be you count from 1 to 100 and backward. So 1, 2, 3, 4, 5, 6, 7, up to 100, and then 100, 99, 98, 97, 96, and on. At this age, he knows how to write A to Z, 0 to 9. He knows how to write his name. Of course, not nice. His hand is too small. Okay, and he starts reading book by himself. Of course, toddler book. Okay, so with that kind of result, okay, I rather my wife not working. Okay, this is her work, and she deserves a lot more pay. Okay, That's why whatever I earn, it goes to our joint. It goes to our joint account, and whatever she earns, it goes to her own account. Okay, and I don't have problem with that though. Okay, yeah, that's how happy I am. So do not look down on a couple. I am for one. Do not look down on a couple in which the wife not working. No, don't look down on that kind of lady. Okay, I will be the first person who actually yell at you if you say anything like that. Okay, you know, there's something more than just money. My wife was an accountant, worked for a very big company. It's an oil company before. Okay, and it takes her a big humility and big heart to leave her job and just focus on her children. Basically, she sees uh, her children education as something with worth more than the pay she would earn if she go back to work and leave the children education to some what do you call it, childcare. Now it's not that I look down on childcare. No, I'm looking at my wife right now. Okay, I'm looking at my wife and I say that I really appreciate her for her sacrifice. Okay, and that's why, because she focused on children, then I have to focus more on working. Okay, yeah, and the fact that when I make a comment about this earlier, the fact that they have 2 or more children and both spouses need to work, they must have a very big challenge, and there's a big sacrifice uh, for them. Well, one of our friends make give me a comment, says that I have benefit from my mom being home too. She was a principal but left the job to be home with me and my sibling. Oh, thank you, you know. And yes, you need to thank your mom for that, you know. Okay, it's more than just money. It's more than just money. Basically, she sees my wife sees my children just like your mom look at you as a greater investment, more beneficial investment, not money wise. It's more than just money. It's happiness. Okay, yeah. Seeing my son able to do such a thing, even if she could not, I'm happy enough. I feel so blessed to have a, 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 a son, and yeah, half a year ago I was blessed with another baby girl. Okay, but even more seeing how they were very well taken care, not only in their health, their well-being, but also in their education, how they interact. Very happy. My son is very cheerful boy. If he comes down, I will show you him. At one time, I remember last year, I brought him to school because there was one day his mom had something to do that she cannot take care Peter, my son. So I brought him to class. So I was going to class. Going into here, right? That's my teacher's desk. And I told my son to sit at the back. He was like 3 years old, no, 2 years old something. On his way to the desk I told him to sit, he actually waved his hand and say good morning everyone to to the students in class. That's so cute, you know. And I remember that moment. It's like, oh yeah, I want him to actually enjoy going to school, not seeing school as something uh, scary, you know. And yeah, he misses school right now. He misses school. Well, anyway, I hope you don't mind me mention things like this, because life is more than just statistic. Okay, in fact, statistics should be a tool, not the end point, not the destination of the learning process. I want this statistic to be a tool for us that we can use in interpreting how well we do as a society, in this case, for example, in fighting for this pay gap. Okay, regardless you believe it's still there or not. Okay, regardless you think we have we still need to fight for it or not. When we look at the numbers, I can say, in my opinion, it's getting better. Should we stop? No, we should not. Okay, we should not stop. In my opinion, we still have that gap, but that gap is actually getting smaller. And of course, it means the way we fight for that is actually getting better. Let me mention one more thing. Okay, now please never, and let me write it down, never interpret what I said in this class about an issue as a support nor against any side of that issue. Okay, so earlier when I talk about the gender pay gap, okay, please don't see that as if I'm against that or I'm for that. Well, yeah, you can see I'm for that, but even if you're against that, I still love you. Don't worry about it. Okay, yeah, but I want you to use statistics to see, using the numbers we have, to see if, regardless, for example, regardless you believe the gender pay gap still there or not, we can see if we are doing well or not in the trend. Another one is this one. I know this could be a bit sensitive, but I'm not in any way trying to offend anybody. I want to see this from a trend, okay? The issue of gay marriage. We have to accept, and I'm honestly, marriage, not marriage, gay marriage. We have to accept that right now that's the law of the land. Okay, but do you know gay marriage fight? The people who fought for gay marriage to be legalized, that kind of effort was not done in a couple years. That was done in decades. Okay, regardless you are for that or against that, doesn't matter. There's something we can learn here. What we did, what they did 50 years ago, of course, 50 years ago, it was a taboo. A lot of people against that, but they fought for that, and more people support that. And right now, at this point, even if we don't look at that from the law of the land, okay, if we just look at the population, more than 50% of our population, even 70% right now, actually support gay marriage. Okay, but if you ask the same question to the population 50 years ago, the numbers is very, very low at that time. But then how do they know that they went to the right direction? Suppose 50 years ago, that was only 20% support. And then years later, they found out it's 30% more. Of course, it's increasing. Would you like that kind of number or not? That's another story. Somebody may say, oh, for 10 years, you only increased 10% of the population. That's not significant enough. That's another interpretation. We need to do another statistical analysis for that. But at least the increase tells us that they are going to the right direction. Can they do more? Maybe. Okay. And then after many years, right now, at one point, I think like around 10 years ago, it was 50%. Right now, especially if the Supreme Court legalized that, it's more than 50%, significantly. I think it's to the point of 70%. My point is, use this as a lesson for our future. How would we fight for certain case in our society? There are things that we need to fight for more than years, even decades. okay? And to see if we are going to the right direction, see the support is increasing or decreasing. Okay, I hope you see about this. Like for example, one thing that I would really like is one thing I really like to do personally is to improve. I have degrees in math, but I have some financial background too. Yeah, and finance background, and I think to improve the trading between countries to lower the costs of import-export. One thing we need to do is to lower the cost of remittance. Do I say it right? Remittance. What is that? It's like, imagine if you have an Indonesian working here like me, Indonesian working in America, and needs to send some part of his salary, let's say my salary, to my parents in US, send money to Indonesia. Now, of course, I will not send all my pay, right? Let's say I want to send $500 every month to my parents. Now, the problem is if I send it through bank, it will cost $45. That's how much it costs. That's too much. Okay, if you send it through Western Union, I think it will cost like $15. That's 3%. I think that's quite reasonable, but if we can lower this even more, let's say it just costs $2, then you will end up having people sending money, even $50. But there will be a lot of people sending $50 every week. Okay, now with more money they have in Indonesia, for example, then my parents, for example, will have more buying power, including buying stuff from America, right? Okay, medicine produced in America, a lot of them actually still being imported to Indonesia. Now then, how do we get to this direction? Okay, now I use Indonesia as an illustration here, but you know, this is more than just sending money to Indonesia. It's more than that. It's sending money to other countries, to Mexico, to Latin America, okay, to Japan, to China, to Europe. Once we can lower the cost of sending money, then there will be more people able to afford buying things across the border. Okay, yeah, that's one of what I would like to see. How do I fight for that? And I do something to show the government later on. But that's something I keep for myself, keep for my family right now. Okay, I'm pretty much done with this 5.2. Sorry for talking too much about this 5.2, but what I explained here actually give us, I hope, give us a pretty good foundation to what we will do tomorrow. Now, in the last 5 minutes, I want to mention this addition formula, general addition. You see this formula in our textbook. Now, I never mentioned this formula for now because we don't need to use this formula, but we will use this formula if. Maybe I write that as a note. Use this only if there is no Venn diagram and no contingency table. Well, even if you have Venn diagram or contingency table, you still can use this general addition formula. However, there will be an overkill. What is general addition formula? Probability of A intersection B, I mean union B, is probability of A plus probability of B minus probability of D intersection. Okay. Now, if we look back to what we did above, you may remember question part D here. Probability of A, no children, or B, husband only, is probability of no children plus probability of husband only, no children, husband only. Okay, but we subtract this 172 because it is double counted. You're supposed to count it only once, right? Because it's double counted, you subtract that once. Okay, now that's the illustration of this formula here. Okay, pictorially, you can see the following. Suppose we have A and B. Now, probability to be in these glasses here, the probability to be in these glasses here is equal to probability to be in A plus probability to be in B. Now, do you notice that you have the intersection double counted? Right? Do you notice that's double counted? Now, then that's why we need to subtract that once so that it is only counted once. Okay, now that's the idea of this formula. That's where this formula coming from. Okay, now do not use this formula all the time. That's not good for you. It will take you too much time. In other textbook, in fact, in more advanced textbook, slightly more advanced textbook, they call this Inclusion-Exclusion formula. Okay, and there will be times where I call that exclusion-inclusion formula. I hope I don't confuse you by doing so. Now, some terminology definition. Events A and B are mutually exclusive. We call that mutually exclusive if they are disjoint. In other words, A intersection B is an empty set. Now, pictorially in Venn diagram, these two events are mutually exclusive if event A and event B has no intersection. Okay, now because the intersection is empty set, so what do you guess the probability for the intersection be? That will be 0. Okay, yeah. If two sets are mutually exclusive, two events are mutually exclusive, the intersection of the sets is empty set, the probability for that to happen is 0. Therefore, the probability of the union of two sets, going back to that inclusion-exclusion formula, it's probability of A plus probability of B minus the probability of the intersection, which we know to be 0. Okay, so if these two sets are disjoint, if these two sets are mutually exclusive, then probability of the union is probability of A plus probability of B only. That's if A intersect B is anti-set. Okay, now tomorrow we'll do more problems from this 5.2. I plan to do 5.2 and 5.3 today. It turns out that I spend more time in doing more problems. If you notice, I spend a lot of time actually for this kind of question here. Yeah, but this actually helps you formulate what's the question and what's the situation. Okay, now suggested homework from 5.2. Yeah, I suggest you to do it, but if you don't, you're fine. Of course, you will be behind after that. I would like you to do number 5 all the way to number, I think number 45 is good enough. Up to number 45. Just do the odd one so that you can check with the back of the book if you have the book. I think I will try to find to post the solutions for these odd problems in our textbook to our file folder. Okay, yeah. Please remind me if tonight around 6 o'clock you don't see it though. Okay, yeah, but I will do so. Okay, see you then tomorrow.
Thank you.